So there's nothing useful happening. So in the same way, even in the production domain, there are time is money. Okay, time is money with respect to production. So the main criteria or the main objective is I don't want any machine or any men. These are all resources. I don't want them to be idle. Okay, so that is my objective. So how do I reduce the idle time to the least? Okay, it's very challenging to achieve zero idle time. Okay, it's very difficult to achieve, or very challenging to achieve zero idle time. There would be a component called as idle time, but we are only looking to minimize the idle time. Okay, right? So the method what you're going to use for this particular sequencing is your Johnson's rule. So I've seen many question papers wherein we teach the sequencing thing, and finally they say solve the particular problem using Johnson's rule. People don't know that this is a sequencing problem. So please make a note that this is the Johnson's rule of assignment. All of you have the PCP material in the hand. Can you work out the problem? Yes. Yeah, definitely. We are going to take up the problems. Not to worry. Okay, I'll ensure that you people have understood the problems. Okay, need not have to worry. I'll solve the problems. Okay, right. So please go through that. Please go through that material. Apart from that, you also need some couple of books which I'll be sharing with you as a soft copy. And also I'll share my notes with you. Okay, so that would be useful for you to understand the concepts. Okay, right? Okay. So proceeding further, you have the Johnson's rule of sequencing, and then you have something called as the game theory. These are all the most important units where you get problems in the examination. You have the game theory or theory of games. So in game theory, what's going to happen is very simple. It's like what's a game? A game is something wherein there'll be two or more players with the objective of winning. Okay, the result or the main motive of a particular player is I have to win the game. Okay, anybody has done the link? Anybody has done the link, so we can share it. Is it going live on YouTube?
No, sir.
Okay. Maybe you can quickly create one and put it. Okay, so it will be beneficial.
Yeah.
Just for today. Tomorrow I'll ensure that the YouTube link also is functional. Okay, no problem. Okay. So just to save.
So yeah. One doubt. After finishing the class, can you share the notes?
No problem. I'll give you the notes.
Can you record the session, sir? Can you record the session and share this?
Can you record the session? Okay, one second. You need me to record this?
So we can able to share the people who not attending.
Okay, one second. No problem. 1 second. Oh, you all admit all.
Sir, good morning, sir. Please send me an WhatsApp link, please. I'm a new student.
News.
Already posted in that group. Already
posted in that group, because I don't know there's some group. Okay, so please join that group.
Again, also just posted.
Please,
sorry.
sir, share the link, please.
Okay, can you add me to that? Can you add me to that group? Can you make?
I just shared now.
Okay, can you add me to that group, please? So that
sir, you will really get bored and you will get disturbed very badly, sir, if you go to the group.
Oh, is it? Okay, fine. Then I am not
unwanted chats and
okay, you want the number? Okay, I will share my number. Maybe if you have any doubts, you can ask me. Okay. All right. Proceeding further. proceeding further, you have something called as the...
sorry for interruption, sir. Guys, I just shared the WhatsApp group link in this chat. So those who are not in the group, please join.
Okay.
Thank you, sir.
Group invite link. Okay, fine.
Thank you, sir.
No problem. All right. Okay, the group is full too. Okay, the group is full too. Can you put one more group? It shows like the group is full.
Yes, sir. Actually, we already have
Okay, I have some very religious person. Okay, right. Bhakti, right.
Sir, please share me one more time, sir, please.
Please share. Can you go to that option? I have another pop-up. It says admit all.
Sir, you ignore that admit all and go for this muting, sir. This problem happens every time when Devamanan sir takes a class. He could never listen to the class at all.
Not only Devamanan sir class, everyone's class.
Sorry, bro. Appa solta. Ella class na.
Sir, you can share the content with the admin, whoever the admin is for the WhatsApp group, so they can share it with.
Done, sir.
Fair enough. Let me share my email ID and my number. So there you have it. Okay. So you can reach out on this. Okay. All right. So what I'm trying to say here is very simple. We'll proceed further with the class. Okay. All right. YouTube. Okay. Is it streaming? Okay. Fine. All right. Yes, sir. Oh, it's streaming. Okay. Fine. So now we will proceed with the game theory aspect. So what is game theory? What's a game? A game is nothing but it comprises of two or more players where the intention of each player is to win the game. So this is what is a game, and the game theory is going to give you different strategies. The game theory is going to give you different strategies to win the game. So what strategy, if you apply, you can better perform than the opponent, player. Okay. So that is what is the theory of games. You have the two player zero sum game. Two player zero sum game is the basic type of game which we will be solving. And again, you have many different methods in that game theory, like your maybe your calculus method or your algebraic method, your graphical method. Okay, so these two methods, you will be getting a lot of problems on game theory. Okay, the remaining aspects are like replacement problems. So replacement problems is like supposing you buy a machinery and the machinery is functional in the production unit. There is a shelf life for that particular machinery, and when do you have to replace that machinery, and when the servicing of that particular machinery becomes very, very difficult, or when the cost of servicing the machinery is pretty much more than replacing it. So that is what you are going to study in the replacement problem. At what time you have to stop doing the particular servicing and replace the machine. Okay. So this is all about the replacement decision. Maybe in your book, it might be like a replacement decision. So that is all about that particular unit. You have three different types of problems which will be coming in that, like your Yeah.
So it's little fast. Can you please go slow? The 3 units, what you said, can you repeat, sir? Because I can't
Okay.
follow the things.
No problem. No problem. Which are the 3 units you want? Game theory?
The theory, yes, sir. What are the theories you said? Can you repeat, please, for once?
Okay, no problem. No problem. See, in your game theory, what happens is you're going to solve a game. Okay, you're going to solve a game using different methods. Your game is basically telling in your game theory, this particular topic is basically giving you strategies to ensure that you win the game. You'll be having an opponent, 1 opponent, 2 opponents, n opponents. So my intention of playing a game is I need to win. So everybody plays a game with an intention to win the game. So what strategy I have to use so that I am performing better compared to my opponents, compared to my competitors. So that is what I'm trying to say here. Okay. So the game theory is going to give you different strategies. Where to invest, where to apply the particular strategy, where to apply the particular strategy is what is game theory all about. Okay. Right. So in that you have many different techniques. The first one is called as your algebraic method or your calculus method. I'm just going to give you the overview. I'm giving the overview. And later on, I'll dig deep. I'll take the problems and I'll ensure that you people solve the problems. Okay. So first one, you have the algebraic or calculus method. Second one, you have your graphical method. In graphical method, again, you have 2 cross m and 2 cross n and m cross 2 matrix. So it branches. In graphical, you have 2 different methodologies, and these are the 2 important things. These are the 2 important things. And then you have another important rule in your game theory that is called as the dominance property. So what is dominance property? Dominance property is basically reducing a higher order matrix. If your matrix is more than 2 cross 2, you have 2 rows, 2 columns, algebraic method is perfectly fine. You have 2 rows and you have n number of columns, graphical method possible. You have m number of rows and only 2 columns, graphical method possible, because the main reason is in your graph you have only 2 axes, x and y axis. So that is why one of the elements, that is your either your row or your column, should be 2 in number. Okay, because it's a 2-dimensional figure, the graph. And then you have your dominance property. Your dominance property is basically reducing the higher order matrix into a 2 cross 2 matrix. Okay. So how do you do that? You have 2 categories, that is your row dominance and your column dominance. So what is row dominance? If the number of rows are more than 2, you use the row dominance and you reduce it to 2 rows.
So dominance properties means it is comes under graphical method, sir?
No. It's a separate rule. It's a separate rule which comes in game theory.
Okay. That is third one. First one is algebraic. Second one is graphical. Third one is the dominance method.
Dominance property. So dominance property is the property where you reduce the higher order matrix into a 2 cross 2 matrix. Okay. Right. Okay. There's another problem which I have seen in one of the question papers. If you see the last 15-year question paper, this particular concept has come only once or twice. So a very good person has said the paper. You have something called as the convex linear combination. A convex linear combination is a process where the dominance property would not be applicable. Even if you are applying the dominance property, the matrix doesn't get reduced to a 2 cross 2 matrix. Okay, right? So I'll be teaching you that particular problem also, so that any sort of problem which comes in the examination, you should be in a position to answer the problem. Okay, right? So understood game theory?
Yeah.
Mohammed? Okay. Oh, somebody is bang on target. Okay, right. Okay, right. So that is game theory. Then you proceed further. you have something called as the replacement problems. Replacement problem or replacement decision is basically arriving at a conclusion or arriving at a standpoint where I want to see whether can I continue with the existing machinery or should I have to replace it. There's a stage wherein you tend to spend more amount of money. Okay, you spend more amount of money on repairing or servicing that particular machinery. So it is better that you replace the machinery so that finally what happens is your organization would be basically looking in for profits, and if you are reducing the cost component, then definitely there'll be an impact on your profits. Very basic rule. That is, you reduce the cost component, then definitely you will have a larger profit margin. Basic economics. Okay. All right. Proceeding further. Okay. Proceeding further. This is your replacement decisions. In that you have three techniques. In that you have three techniques of replacing the machinery. The first one is called as the CRS model. CRS model. You have your that's the first model, and then you have the CRB model. Okay, CRB model. And the third one, you have the model as group replacement. So any one model definitely will be getting your problem. Either your CRS model or CRV model or your group replacement. These are the three techniques which are coming in your replacement problems. Okay. Have I skipped any other part in that? Can you read out the topics?
So I think, have you heard CPM?
Okay, network analysis. So next component is called as the network analysis. So network analysis is again basically it's a kind of sequencing wherein I want to know what is the probable duration. I want to know the probability of finishing a particular project. Okay, it's like am I going to finish my project on time, or is there a delay? If there is a delay, what is the amount of delay which is for which the project is going to be lacking? Okay, so it's like 10 days delay, 15 days delay, it can be anything. So this is basically your PERT and CPM. It's abbreviated as project evaluation and review technique, and your critical path method. So basically what happens here is you're going to review the project. You're going to see where exactly the project is lacking, where you need to speed up the operations. So in that you have we have 100. Okay, I can't admit. Okay, so in that what's happening is very simple. You form the network diagram. Yeah, in the network diagram, you have certain rules of constructing the network diagram. You just cannot construct the network diagram as it is. Okay, so okay, I cannot move one. All right. Okay, so there are different rules in which you can construct the network diagram. The rules are given by Focussen's rules of networking or network diagram. In that, it's like you start from the left, you proceed to the right. Okay, this is the first rule. Second rule, the activities should be specific. No activity should be repeated. Okay, and no activity should cross each other. So there are many different rules. Sure. Now
you are speaking about network analysis.
Can anybody mute? I'm not able to listen.
Sir, can you just explain network analysis once again?
Okay, network analysis.
Network analysis, sir?
Yeah, network analysis. The main heading is network analysis. It's branching into two types. One is called as the PERT. Another one is called as the CPM. Can you please mute, because yeah. Thank you so much. Appreciate it. So what I'm trying to say is network analysis is a broad topic. Under network analysis, you have two subdivisions. One is called as the PERT, another one is called as the CPM, critical path method. So in PERT, you have the project evaluation and review technique. You want to know what is the duration? What is the duration of completing a specific activity or completing the entire project? That comes under PERT. In critical path method, you are finding out one very important thing that is called as the critical path. What is critical path? Critical path is the longest path. What is the maximum duration? What is the maximum duration which the project is going to take? Okay, or it's like I can't explain it. When I'm taking the problem, it will be more clear. It is the longest path in the what do you say, in the activity or network diagram. Okay, so network diagram you need to draw, and that's the longest path. As of now, you just remember that critical path is the longest path in the network diagram that has the same forward and backward computation times. Okay, so that is what is critical path method. That is what
actually CPM, like the entire what are the possible paths it can go to finish complete a program, right? Is that the way you're trying to say?
Okay, see, critical path method, how do I say? See here, I'll just give you a small example. Let me say there are 4 activities. I am presenting my screen. Are you all able to see it?
Yes, sir.
Yes, sir.
You are able to see my screen?
Yes, yes, yes.
Very nice, very nice. Okay, okay. Sorry?
Sir?
But not the notes which are
I can't see, sir.
Listen. If you are not able, listen up. Sorry to interfere. If you are not able to see my screen, it means to say that the network is low at your end. Okay. So please boost up your connection. Okay, fine.
Sir,
Okay.
Only one suggestion from my side, sir.
Yeah, please. Any particular problem, please let me know.
We can't able to create the YouTube link, sir. Better you can create it. Yeah. We'll try to create it. You can create the link and share the link, sir.
Okay, I will do that.
Okay, thank you, sir. Thank you.
Can you see my screen? Can you see my main screen?
Yes.
Yes, sir.
Oh, right. Now you see here, I just want to say a few things. Let me say I want silence, please. Please mute. Please mute so that it will be more effective. Okay, see, let me say that there are 4 activities. Okay, let me say there are 4 activities like A, B, C, D, or let me say 5: A, B, C, D, and E. Okay. Now, first activity is A. Okay, last activity is E. So this is the starting event. This is the starting event, and this is the ending event. Oh my God. Okay. Listen up. Okay, so this is the starting event. This is the ending event, and you have everything in between. Let me say it branches like this. From A it goes to B. Okay, and then it goes to B, branches out to C and D.
Are you sharing any slides or else any screen?
I am not
able to see your face only.
Oh, is it so? I am not able to see my
bro, sorry for interrupting. Bro, மேல வந்து பின் சிம்பிள் காட்டுது பாத்தீங்களா ஸ்கிரீன்ல? சாரோட டிஸ்ப்ளே பக்கத்துல மேல பாத்தீங்கன்னா ரைட் ஹேண்ட் கார்னர்ல பின் சிம்பிள். அதை கிளிக் பண்ணீங்கன்னா சாரோட ஸ்கிரீன் வந்து உங்களுக்கு ப்ரொஜெக்ட் ஆகுது.
ப்ரோ சாரோட ஃபேஸ் மட்டும் தெரியுது ப்ரோ, அந்த ஸ்கிரீன் தெரியல.
அது பக்கத்துல ரைட் ஹேண்ட் கார்னர்ல வந்து பின் மாதிரி சிம்பிள் இருக்கு பாருங்க, பின் சிம்பிள்.
அதை கிளிக் பண்ணாலும் ஒண்ணும் வரல.
கிளிக் பண்ணீங்கன்னா சாரோட இந்த இன்டர்ஃபேஸ் காட்டுறாங்க. கூகுள் இதுல லாகின் பண்ணி
they will stream it live on YouTube as well as the Google Meet. Okay, not an issue. Just try to adjust first class. Okay, if you want me to repeat this class once again, no problem, I'll repeat. Absolutely no problem. Inform people not to get disappointed. Definitely I'll if I have to repeat this class once again, I'll do that. Not an issue. Okay, right? Okay, so proceeding further. Okay, admit all. There's some few people who have left. Okay, so as of now, anybody can join, right? Fine. Okay, there are 100 people exactly. Okay, so proceeding further. I forgot where I was. I was in that network analysis diagram. Okay. Oh, you all mute. No problem. I got it. Okay. So we were seeing the network analysis. One student said, those who want to join Facebook, please. Okay. Right. So what I'm trying to say here is very simple. What you can do is in the critical path method, you have different activities. Okay, you have to reach from the start to the end. Unless and until you analyze all the paths, you would not be in a position to find out which is the longest path. Fair enough. See, supposing I want to travel from here, from T Nagar to let me say Besant Nagar. Okay, I want to go to the beach. From T Nagar to Besant Nagar, I want to travel. So I have different modes of transport. Either I take my bike, or I take my take my bike, or I take my car, or I go by public transport. Let me consider these three things. Unless and until I travel by all these three modes, I will not be coming to a conclusion as to which is the mode of transport which is taking the highest amount or maximum amount of time. Okay. So the critical path is like, unless and until you analyze all the paths in the network diagram, I would not be in a position to find out which is the longest path. Understood? So this is what is critical path method. PERT, project evaluation and review technique, where you find out whether the project is going on time, off time, what is the deviation, etc. In critical path method, you're going to find out what is the longest time which can be allocated or which is taken by the project to execute it. Okay. Let me give a very simple example. It is like when I was in school, the maths teacher used to take the class. Okay, when the maths teacher, she used to take the class, and after she completes the class, she will pick out the dullest student and she will ask a question. Okay, if the person has answered the question correctly, she comes to a conclusion that okay, which means to say that most of the people would have understood, or the class has understood. So that is how it works. So if you come to know what is the critical path, then definitely you know what is the longest time, or what is the duration which is the longest for the project to be completed. Thereby the other parts, either you can consider or you do not have to consider, but my main motive is I have to finish or complete the project in the least possible time. Okay, I have to complete the project in the least possible time. So that is what is critical path method all about. So this is the network analysis. So you have different kinds of concepts like your free float, independent float, okay, total float, earliest start, latest start, earliest finish, latest finish. You have many different concepts. So as and when I take the problems, I'll definitely explain it to you what this is. One thing, please don't miss the class so that you maintain continuity. This is one type of subject wherein you miss a class and the concept would not be followed, okay, in the next class. So just try to attend all the classes. We'll try to give you the best possible information. Okay. All right. Fine. Okay. So Any other, what's the next topic? Any other topics which I've left out? Your screen is still visible to others. Okay. Any other topics I have left out? Super, sir. Super for what?
So game theory and strategies, sir.
Okay. Game theory, yeah, I discussed game theory. What's a game? What is two-player zero-sum game? What is dominance property? What is algebraic method or calculus method? What is the graphical method? So I have explained that. You want me to explain it once again?
The duality and primal duality, sir.
Sorry?
Duality.
Duality of linear programming problem. Duality is basically conversion. Duality is basically conversion of rows and columns. That is, when you take up the linear programming problem, you're basically converting the basic variable or decision variable x1 and x2, y1 and y2 as y1 and x1, y2 and x2. This is the concept of duality. So duality is basically seeing whether the linear programming problem has any other possible solution apart from the optimal solution. That is duality. Any other concept?
Sir, I have one more doubt, sir.
Yeah. All doubts welcome. Whatever is the doubt, please throw it.
Can you explain the duality once again, sir?
Sorry?
You are explaining about duality concept, no, sir. X1, X2.
Okay. Yeah. So duality is basically, see, dual means what? Two. Okay. So duality means I am checking whether the particular linear programming problem has another solution apart from the optimal solution. Does the linear programming problem has an optimal solution, which is, does it have a solution apart from the optimal solution? There are two different solutions. It's like, how do I say? It is like, okay, I'll give an example. Now, let me say I'm going and writing the examination. Okay, the subject is operation research. I'm going and writing the examination on operation research. So my main idea or my main motivation, my main motive is I have to ensure that I get the maximum. So maybe 95, 100, whatever it is. Okay. Apart from that, is there any other person who is writing that particular examination? Is he also in a position to get 100? Yeah, of course, there are. So that is what I am trying to say. That is what duality says. Is there any other person who is on par with the optimal solution? That is what is duality. Is there any other solution? Most of the problems in linear programming problem would definitely have one optimal solution, but there are cases of linear programming problem which is dual, more than one solution, or there are problems of linear programming problem where there are no solution. Okay, so you don't arrive at a solution. That's called as degeneracy in linear programming problem. Okay, all right. Somebody is presenting my screen. I can see my picture for the first time. Okay, all right. Okay, right. So got the point. Any other concepts which I have left? Any other concept which I have left? You can let me.
No, sir.
No, I've covered most of the things. So this is the overview of the subject. What the subject is all about. First main thing, whenever I start the subject, I basically touch upon all the topics so that you would be curious. Okay, you would be very enthusiastic to know that okay, I'm going to study all this, and it doesn't end just by studying. Okay, it doesn't end if you just study. Okay, I want you people to apply the concepts. So the concept application is possible.
Sir, I think you missed the queuing theory.
Queuing theory. Okay, queuing theory. Okay, thank you so much for highlighting that. Queuing theory is very, very simple. So what is queuing theory? It is like, let me give an example. Okay, all of you have gone to cinema halls. Cinema theater. Yeah. Here I get nice answers. Okay. All right. So all of you have gone to the cinema hall. It is nowadays where people have the app. Okay, book my show, whatever it is. Okay. Earlier, what used to happen? People used to go and stand in the queue to get the tickets. All right. Even now, if you go to different places like your PVR, Escape Cinemas, Satyam, so on and so forth. If you go there, there are many different counters where people issue the tickets. Okay. How do they keep the counters? 5 counters, 6 counters, 7 counters. How does one arrive at the number of counters? It is basically application of the concept of queuing theory. They apply this concept. How? Let me say there are 10 screens. Let me say there are 10 screens, and in each screen there are about 80 people. 80 people can be accommodated in each screen. Supposing. Okay. So 80 people are accommodated in each screen. So there are totally how many people? Totally 10 screens, 80 people. So it would be 800 people. Okay. 800 people can watch the particular cinema. Okay. In different screens at a time. Okay. 800 people. All right. So now, what is the time duration? Let me say, I want to make 5 shows or 6 shows per day. I want to see what is the interval which I have to give. Okay, I want to see what is the interval which I have to give. All this calculation is possible only because of queuing theory. How much amount of time is spent on each customer? Okay, so a person comes, he asks me which show, what is the show, he needs to choose the seat, so on and so forth. So there is a time period for each and every customer, okay, who wishes to watch a cinema in your hall. So that particular time is called a standard time. That multiplied by number of people in each counter. Okay, in each counter, how do you serve the customers? Based on that only, they will say 5 counters is enough, 8 counters is enough, 10 counters is enough, 2 counters are not enough. They would come to a conclusion based on all these considerations. They will see, okay, interval is for 10 minutes. I have to do so much of business in that 10 minutes. So how many counters I have to keep? What should be the serving time for each customer? Okay. So all these concepts you are going to basically analyze only by using the queuing theory. Understood? So you have many different terms in queuing theory, like your jockeying, reninging. Okay. So I'll be explaining all that when I'm taking that particular concept. Understood? Any other topics which I have left? You can let me know. No, 100. Okay. Any other concept? That's all. So can we get into the subject? Are you all interested to study the subject? So basically, it's not just directly going into the subject. One needs to know why exactly you are studying the subject and what are the things which is there in this particular subject. Very, very important. Any subject for that matter, please understand why you are studying this subject and where can I use this particular subject. Very, very important. So that is what I have shared with you right now. So going ahead, I will be touching all these concepts in detail so that you will understand the topics. Okay? Fair enough?
Okay.
Oh, right. All right. So where do you want me to start? You want me to start where? From linear programming? From
the beginning, sir.
From the beginning. Okay. Right. All right. So let me start with linear programming. Okay. Let me start with linear programming problem. Okay. So in this, definitely you're going to get problems on, maybe most of the time simplex method. So it's a 20-mark compulsory question. Either you would be getting a compulsory question for 20 marks from simplex method, or you will be getting it from PERT and CPM, network analysis, or you will be getting it from group replacement. And of late, if you see some few papers, they are also giving you from this one. What is that? MODI method, modified distribution method.
MODI method means it's assignment problem or transportation problem?
Transportation. Assignment is basically Hungarian method of assignment. You have 4 different types of assignments: balanced, unbalanced, restricted, and maximization. Those are the 4 types.
Okay.
Sir, TST you have not explained, no, sir?
Traveling salesman problem.
Traveling salesman problem. Okay. What is traveling salesman problem? Very simple. Again, it is following the concept of your sequencing. It is like, let me say there are 4 places. Supposing you are going, this would be more apt. Okay. Supposing you people want to go to a vacation. You have 10 days. Okay. You have 10 days to enjoy your vacation. So let me say I start from Chennai. Okay. Let me say I start from Chennai. I go to Bangalore. Okay. Then I go to Kerala. No, I don't want to go to Kerala. It's too much. From Bangalore, I go to Hyderabad. From Hyderabad, I go to Delhi. From Delhi, I go to Agra. And from Agra, I come back to Chennai. Okay. Now, have I touched the same place more than once?
Actually, no.
Actually, no. And you don't even want to touch it, correct?
Oh, yes. So true, sir.
Because see, I have 10 days. I want to see new places. I don't want to be like my house is in Chennai. So I want to go to Bangalore. So I go to Bangalore. Again, I come back to Chennai. Okay, fine. Then now I want to go to Hyderabad. From Chennai, again I go to Hyderabad. No, it doesn't work like that. You're going to waste your time. You're going to waste your energy. You're going to waste on your money. Correct?
Yes.
So my idea is very simple. What is my idea? My idea is I have to be effective in my journey. I have to ensure that I don't reach the same point in between. It is like, see, suppose very simple example, even better example. Supposing I am a T Nagar, I want to do some shopping. I go to Saravana store. I don't come back. I do all the purchasing. I go to Saravana store. I go to Kumaran. I go to Nalli. I go to Chennai Silk. I go to GRT. I go to RMKV, and I come back. You get my point?
Yes, sir.
Yes. It is not like I go to Saravana store and come back. And again, from my house, I go to RMKV and come back. However, now people are doing that because in Saravana store only they will purchase so much. There's no place, so they will come, keep the luggage, and go back once again. Okay, second round. All right. Okay, so this is how it is working. Okay, so this is how it works. So a traveling salesman problem is very simple. What he says is, I have to ensure a specific route. I have to find out a specific route wherein I start from a specific place. I complete all the projects or I complete all the tasks wherever possible or wherever allocated, and finally I reach the same starting point. That is what is traveling salesman problem. Understood?
Yeah, sir.
Yes, sir.
First you need to understand the concept. Only then you can solve the problem. Understanding? Blindly you should not take up the problem. You should first understand why am I studying this problem, what is the concept of this problem, and where I can apply this problem. Very, very important. Blindly, you should not solve the problem. Okay, that is my way of explanation. Understood?
Yes, sir.
Okay, right. So proceeding further, any other topics if I've left, you just let me know. Then I can start with linear programming problem.
Sir, you can start with the problem, sir.
Okay. I will start with the problem. Okay. All right. So linear programming, very, very simple, easy way of getting your marks. 10 marks or 15 marks easily you can get from this particular topic. Okay, linear programming problem, or it's also abbreviated as LPP. Okay. Now, when I was explaining the particular class, the intro, I gave a very important point in linear programming problem, that is the linear programming problem. Any linear you can all make notes, please. You can all make notes. If it was an offline class, I would mandatorily say get 150 pages notebook. Okay. All right. So now it's online, so I have very less interference. So what I'm trying to say here is very simple. In linear programming, any linear programming problem, any book, any linear programming problem will have 3 parts. Remember the 3 parts. Always it will start with the objective function. That's the first thing. Second thing, set of constraints. Third thing, non-negative restriction. Okay. So these are the 3 things which will come in any linear programming problem. Okay. Now, how do you identify the objective function? Very, very simple. Anything that starts... Sorry?
Once again, you can say the 3 parts, sir.
Okay. The first one is called as the objective function. Objective function. Maybe I can...
Yes, sir.
Maybe I can type it off. Objective function. Right? Can you see the screen?
Yes, sir.
Objective function. Then you have...
No, sir.
No? Okay. Non-negative restriction. Okay. Thank you so much, Ravi. You have made my job easy. Okay. Non-negative restriction and... okay. Non-negative restriction, and you have your set of constraints and your non-negative restriction. Any linear programming problem will have 3 parts. Okay. Right. So moving ahead further. How do you identify the objective function? It will always start with a maximize or minimize followed with a z. Okay, it will always start with something as max or min z. Are you getting my point? At least you can see the chat box. I have typed it. You will either get it as max or min z. So what is this maximization? What is this minimization? Very simple. Maximization means you're maximizing the profits. First thing, maximize means what am I trying to do? I am maximizing the profits, and that is my intention. Okay. What is minimizing? Minimizing means I'm going to minimize my losses. Either ways, it's the same thing. Okay. One more thing, what you have, book name, please. Quantitative. Yeah, I'll give you n number of books are there. Okay. Not to worry, just attend my classes. That's more than enough. Okay.
Given in sir, maximize be given in the question.
Sorry.
Will that be given in the question, the maximize or minimize?
All the three parts will be given in the question, and maximize and minimize also will be given in the question. Okay. So maximizing the profits and minimizing the losses. Fair enough. Very good. Okay. So what that means is very simple. Either ways, it's the same thing. I'm either maximizing my profits or I'm going to minimize. If I minimize my losses, definitely it's indirectly contributing to profits. Fair enough. Okay. Now, one thing you need to note, if at all your problem is maximizing, definitely this will not be given in your textbooks. This is out of experience. Okay, we have solved thousands of problems, and this is out of experience. If you are solving a maximization problem, linear programming problem, definitely your particular answer, the linear programming problem answer, would be positive. It will be positive. Okay, right? So positive, definitely it will be positive. If you get a answer as minus, and if the problem is maximization, please go check the problem. See, as soon as you finish the paper, you can clearly say, I'll be getting 95, 96, 97, 98 or 100. Or I'll be failing my paper. Need not have to wait for the result. As soon as you finish the problems, you can clearly get your score. Okay. So I'll be giving you various tricks and techniques wherein you can clearly say that, yes, this answer is correct. Yes, this answer is wrong. Okay. You can check it then and there itself as soon as you get the answer in the examination hall. So first thing is very simple. If you are solving a maximization problem, definitely your answer would be positive. It cannot be negative. Okay. Your profits cannot be negative. Okay. Either way around, the other way around, if you're solving a minimizing problem, definitely the answer would be negative. You will be getting an answer in negative, minus 45, minus 50, minus 500, whatever it is. Okay, understood? Understood?
Yes, sir.
Yes, sir.
Oh, okay, right. All right. So this is how the problem works. And then again, moving ahead further, you have the set of constraints. So what is set of constraints? Set of constraints is basically what is stopping me from reaching my objective. What is stopping me from reaching my objective is my set of constraint. Constraint means what? Something is stopping me from achieving my objective. Okay, let me say, people want to attend my class and get the information, but Google doesn't allow more than 100. So that is the constraint.
Obstacle.
Correct. Obstacle. Very nice. Okay, so that is how. Even if you are taking an organization, any organization for that matter, if there is an objective, definitely there will be constraints. There will be problems. Okay, there will be problems where you will be facing maybe while execution when you are trying to reach the objective. Okay, as simple as that. All right. So this is called as the set of constraints. Okay, and one more thing you need to know. If at all, make a note of this point. If the objective function is maximized, definitely the set of constraints will be less than or equal to. Okay.
Yes, sir.
Definitely, the set of constraints would be less than or equal to. If it is greater than or equal to, supposing they have given greater than or equal to, no problem. you may not have to worry about that. Even if it is greater than or equal to, you can go ahead and proceed the problem. But people usually don't do that. Okay, if it is a linear programming problem, definitely maximization problem, it would definitely be less than or equal to only. But however, if you get problems greater than or equal to, absolutely no problem. We can still solve the problems. Okay, absolutely no problem. I'll tell you how you have to solve the problem. Okay. The next point which you have to notice, any inequality means what? Greater than or equal to, less than or equal to. These are all called as inequalities. Understood? This is all basic maths. So less than or equal to is an inequality. Greater than or equal to is an inequality. Okay, if it's exactly equal, no problem. Okay. Now what happens here is, if there is an inequality, when you multiply it with a -1, the inequality sign changes. Let me say for example, my current value is -35. Okay. Now -35 is not acceptable. I want to make it to positive. What is the operation I do?
Multiply by -1.
Very good. So I have -35. If I multiply with -1, okay, so I get it as plus 35. Is that right?
Yep.
Right?
Right, sir.
Okay. So any inequality, when it is multiplied with a negative sign, then definitely the inequality sign changes. If it is less than or equal to, and if I multiply it with a -1, then that inequality becomes greater than or equal to. If the inequality is greater than or equal to, and if I multiply it with a -1, then it changes to less than or equal to. Remember this.
So can you repeat once again, sir?
Repeat the last point once again.
Any inequality, if it is less than or equal to, if you have a inequality as less than or equal to, if you multiply that with a -1, that less than or equal to becomes greater than or equal to. Correct? No?
Sir, you mean vice versa, sir?
Sorry?
Vice versa.
Even the same thing happens greater than or equal to when multiplied.
Adeda. Seriya? Okay, so what I'm trying to say here is, whenever you have an inequality, and if that inequality is multiplied with a negative sign, the inequality changes. If it is less than equal to, it becomes greater than or equal to. If it is greater than or equal to, it becomes less than or equal to. The only thing is you need to multiply it by -1. Understood? Get my point?
Yes, I got it.
Okay, right. So this is one more thing which you should know. Okay. So this is the inequality with a minus sign, -1. Then you have something called as the non-negative restriction. What is non-negative restriction? It is very, very simple. Your decision variables, when you are solving the linear programming problem, should always be greater than or equal to 0. Okay, that is the condition which they have kept in the linear programming problem. My decision variable or basic variable, like your, let me give an example. Give me a example of a linear equation.
2x plus 5y equal to 2 something.
Okay, 2x plus 5y equal to 2. Okay, 2x plus 5y is equal to 2. Now this x and y is called as basic variable. Okay, and the coefficients are 2 and 5. Are you getting my point?
Yes, sir.
Right? So this x and y cannot be 0. That's what he says. If it is 0, what happens is 2 into 0 and 5 into 0 becomes 0.
Yes,
so you would
sir.
eventually not reach any solution other than 0. That is why there is a restriction. There is a restriction which says I always want my variables to be greater than 0. Non-negative. I don't want that variables to be negative. That's the restriction what is being demonstrated in the problem. Okay. So these are the.
Sir, you mean it shouldn't be 0 and it should not be negative.
Correct. Okay. So that is the restriction what they have kept. Preferably positive. Okay. So this is the 3 parts of the linear programming problem. Okay. So how do you solve the particular problem? Okay. How do you solve the particular problem? Okay. Very simple. Okay. What do? We will take up one problem and simultaneously we will solve that problem. Okay.
Okay. Sure.
Okay. 1 second. Let me just take one step. All right. Okay. We will take one problem and we will solve. Okay, give me some values.
Maximize z equal to.
All of you take down. Maximize z equal to
8x1 plus 10x2
plus 10x2
plus 7x3
plus 7x3.
Then the determinants, the constraint.
Subject to, yeah.
Subject to. X1 plus 3x2. X1 plus 3x2.
Okay.
Plus 2x3.
Okay.
Less than equal to 10.
Okay.
Second constraint. Minus x1. Minus 5x2.
Okay.
Minus x3. Greater than equal to minus 8. The last constraint x1, x2, x3 is greater than equal to 0.
X1, x2, x3 greater than or equal to 0. Okay, what is the heading?
Simplex method.
Simplex method. Okay.
So once again, repeat the question, sir.
Okay, I will repeat the question. It says maximize z is equal to 8x1 plus 10x2 plus 7x3. Okay, subject to x1 plus 3x2 plus 2x3 less than or equal to 10 minus x1 minus 5x2 minus x3 greater than or equal to minus 8. Okay. Then last non-negative restriction. See, non-negative restriction always greater than or equal to 0. It says x1, x2, x3 greater than or equal to 0. Okay. So I hope all of you have written down this problem. Okay. Now you see here in this particular problem, it says maximize. So maximize means I am going to maximize my profit. If you see the constraints, I told you that whenever there is a problem with respect to maximization, all the set of constraints should be less than or equal to. But if you see the second constraint, it clearly is greater than or equal to, which means to say what? The examiner who is taking the question paper purposely wants to confuse the candidate. Okay. He really wants to find out whether the candidate knows the concept. Now you see here, if you see the second equation carefully, everything has a minus sign with a greater than or equal to sign. Correct? Huh?
We can't follow, sir.
Yes, sir. Yes, sir.
Sir, please. We can't follow. It's very fast.
It is very fast.
Even yes, please, someone, friends, can you put the back camera? Who are all note down the question? Because many people are not.
Yes, sir.
Can you see the question? Can you see?
Yes, sir. Now it's easy, sir. Please, can you please, sir? We'll note down the question, sir.
Yeah, please.
Sir.
Okay. Can you all see the question?
That third one is
Yes,
x1,
sir.
comma, x2, comma, 3, sir. That is comma, sir. x1, comma.
Sorry?
Next.
So can you show that questions again?
Greater than 0.
Greater than or equal to 0.
Thank you, sir.
Okay. Randomly I'll see. Okay. Okay. If you see the second constraint, okay, I'll get a board. That's better. Next class, let me see if I can get a whiteboard. So you'll be more attentive and you can. Yeah, it'll be more easy to follow the lecture. Okay.
Thank you.
You have
Okay,
a
sir.
whiteboard in Google Meets.
Sorry.
You have a whiteboard in Google Meets.
You have a whiteboard in Google Meet, but again, that is time consuming.
Okay.
I need to write. So I'll take a marker and solve it directly on the board. So it will be faster. Okay, right? So now you see.
Sir, or else if you are using a mobile phone, means you can go with a back cam, so that switching on the back cam, you can work out through a paper itself. Notepad la நீங்க டைரக்டா நீங்க வொர்க் அவுட் பண்றதை என்னால பேக் கேம்ல பார்க்க முடியும்.
அப்படியே சரி.
அது ரொம்ப ஈஸி. ஒயிட் போர்ட்னா நீங்க எழுதிட்டு அழிக்கணும். உங்களுக்கு நோட்பேட்ல நீங்க எழுதுறது நாங்க ஃபாலோ பண்றது ஈஸியா இருக்கும். நீங்க வொர்க் அவுட் பண்றதை டைரக்டா எங்களால விசிபிளா பார்க்க முடியும்.
No, can you see if I place the board here? Can you see?
Yes, sir. Yes, sir. Yes, sir.
Yeah. That's okay, sir.
If I place the board, can you see?
Yeah, that's okay. That's okay.
Yes, sir. Yes, sir.
Okay. Next class, let me just buy one board for you. Okay.
Sir, instead we can go with your back cam, sir, because you need not, erase it and you do not write it that way. அப்படியே பேப்பர்ல எழுதுனா எங்களுக்கு அப்படியே பேக் கேம்ல தெரியும், ரிஃப்ளெக்ட் ஆகும் அப்படியே.
சார் அது ஈஸியா கூட சார். ஏன்னா நீங்க அதான் சார், நீங்க சப்போஸ் மொபைல் போன்ல நீங்க கிளாஸ் எடுத்தீங்க அப்படின்னா பேக் கேம் போட்டீங்க அப்படின்னா டைரக்டா நீங்க நோட்லயே ஒர்க் அவுட் பண்ணிடலாம். பட் போர்டுன்றப்போ சில பேருக்கு கேமரா கிளாரிட்டி இருக்காது, நெட்வொர்க் இஷ்யூ ஆச்சுன்னா கஷ்டமா இருக்கும் சார். உங்களுக்குமே அதை அழிச்சிட்டு எழுத கஷ்டமா இருக்கும். நீங்க நின்றுட்டு தான் இருக்கணும், உட்கார்ந்து எழுத முடியாது. அது உங்களுக்கு சிரமம் சார்.
Just wait, let me get my phone, see if it is possible, see if it is okay for you people. Okay, 1 second.
Sir, we can manage now.
We can manage now. Tomorrow, if it is possible, next class onwards.
Yeah, from tomorrow.
You can join with mobile as well as laptop, sir.
No problem. I will join with both so that you can see my notes. Okay.
Thank you, sir.
In which I can work out. Now you see here.
Thank you, sir.
Okay. Now you see in this concept is very simple. If you see the question carefully, in the second equation, all the coefficients are negative. Can you see that? Minus x1, minus 5x2, minus x3 greater than or equal to minus 8. Correct?
Yes, sir.
So the examiner wants to confuse you people. He wants to see whether you people know that concept. That is, when I when I multiply this particular equation with a minus sign, this inequality becomes less than or equal to. If you don't know that concept, students would not proceed further. You cannot proceed further because you will be like, yeah, maximize, okay, it has to be less than or equal to, fine, but one constraint is greater than or equal to, what do I do? Question mark. You don't know, okay? But now, since I have given you the concept, very easily you can solve the problem. What you need to do, go to the second equation, you need some correction there, okay? You need some correction there. You cannot proceed further as it is. So what you do, you multiply the entire second equation with a minus 1.
Okay.
Okay. So what happens there? First, you have to rectify the problem. So that equation becomes x1 plus 5x2 plus x3 less than or equal to 8. Correct?
Yes, sir.
Yes, sir.
Right. Okay. So that is the first problem which you have to rectify. I want maximize. I want my constraints to be less than or equal to. Very, very basic problem, basic standardization of the problem. Okay. Right. Continuing further. Now you have to put a table. You have to put a table. What is that table? The table is called as the simplex table. What is simplex table? I am carefully going to arrange all the coefficients of my objective function, set of constraints, okay, and the coefficients of the decision variable as well as the maximum allocated resources, in a tabular form, So the table goes very simple. It goes like CB, XB, X1, X2, X3, S1, S2, S3, solution, minimum positive ratio. This is the table. Okay, I will again tell it. So first one is CB. Okay, C with a
subscript.
Yeah, C with a subscript B. Okay, if you can mute your mics, it'll be good. Okay, C with a subscript B. Okay, CB. Then you have XB, CB, XB. Now you see in your problem, you have three variables. In your problem, you have three variables, that is X1, X2, and X3. You have three variables, X1, X2, X3.
Sir, sorry to interrupt you, sir. ரொம்ப கஷ்டமா இருக்கு சார், சுத்தமா புரியல. நான் மேக்ஸ் சம வீக் நாங்க.
அப்படியா?
யாராவது நோட் காமிங்க ஷேர் பண்ணுங்க.
நோட் எடுக்க முடியல, என்னால நோட் எடுக்க முடியல. கொஞ்சம் கஷ்டமா இருக்கு.
யாராவது எழுதுறவங்க வந்து நோட்ஸ் அவங்க பேக் கேமரா காமிச்சா நல்லா இருக்கும். ஏற்கனவே அட்டெண்ட் பண்றவங்க
ரொம்ப யூஸ்ஃபுல்லா இருக்கும்.
How many columns you want? How many columns you want for the simplex table? One second. Let me admit some people. Okay. Okay. So I want to see how many columns I need for my simplex table. If you see properly, there are three decision variables. Let me first tell you there are three decision variables: X1, X2, X3. These three are the decision variable or basic variable. Okay. So now you need, after CB, after XB, you need three columns. Okay, you need three columns because there are three basic variables. So I will put after XB, X1, X2, X3. Okay, so there are three decision variables which I have included. Okay, apart from that, now I have to take into account this inequalities. Can you see in the objective function, there are in the set of constraints, if you see, there is inequality, less than or equal to, less than or equal to. So I need to make it to equal to. I have to first remove the inequalities. So what I do, I add a variable called as slack variable. I add a variable, I will type it. I will add a variable called as slack variable. I will add a variable called as slack variable. Okay, that is abbreviated in the form of capital S. That is abbreviated in the form of capital S. Okay, so slack variable S. Okay, now how many basic variables are there? That many slack variables you have to add. Okay, so x1, x2, x3, 3 variables, so 3 slack variables, S1, S2, S3. Okay, S1, S2, S3, 3 slack variables you need to add. Okay, then proceeding further, you need some solution. Solution is basically whatever value, okay, is basically whatever value which is after the inequalities. So after the inequalities, what is the value you have? 10 and 8, correct? 10 and 8. Those two values are called as the solutions for equations 1 and 2. Okay. So what I am going to put? S1, S2, S3, then solution. That is the next column. And then last column is called as your minimum positive ratio. Minimum positive ratio. That is the table. Minimum positive ratio. Minimum positive ratio. So this is your simplex table. This is your
all problems, sir.
Sorry?
Is it common for all problems?
I will tell you. This is common for all problems, but only thing is the decision variable and the slack variable will change. If you have only 2 decision variables, you will have x1 and x2, s1 and s2. Now the problem which I don't know which student has given me, this problem has 3 variables, x1, x2 and x3. Okay, 3 variables are there in this problem. So 3 slack variables will come in this problem. Okay, are you getting my point? So 3 slack variables will come. How many ever basic variables are there, that many slack variables will come in your problem. Understand that. Okay. So here x1, x2, s3, s1, s2, s3, solution, minimum positive ratio. Okay, understood. Now above xb, you need to put cj. Above xb, you need to put cj like this. Can you see it?
Yes, sir.
Okay. Above xb, you need to put cj. Okay, that is also one more element, that is coefficient of your objective function. See, books don't give you this. Cj is coefficient of your objective function. Okay. Cb is called as cost of basis. CB is called as cost of basis. Okay. XB is called as value of basis. XB is called as value of basis. X1, X2, X3 are called as basic variables. X1, X2, X3 are called as basic variables or decision variables.
So CJ is called as coefficient of
objective function.
Oh.
Objective function. CB is called as cost of basis. XB is called as value of basis. Okay, X1, X2, X3 are called as basic variables or decision variables. S1, S2, S3 are called as slack variables. Okay, solution, there is no such explanation for that term. Minimum positive ratio is also self-explanatory. Okay, that is, there is a formula, okay, for minimum positive ratio, that is solution divided by corresponding value in the key column. So you can make a note. Minimum positive ratio is called minimum positive ratio is equal to solution divided by corresponding value in the key column. Corresponding value in the key column. Okay. So that is what is the formula for minimum positive ratio. Okay. Now proceeding further. Yeah. Don't worry. I will give you my notes. Okay. Mute. Okay. Thank you. Okay. Now, first we will start with CJ. All of you should see. Listen. All of you should have a notebook, a calculator, okay, and whatever is the stationery, pen, pencil, scale, etc. Okay, right? You need everything. Regarding the calculator, you can purchase Casio FX 991 MS. I will type that in the chat box. So you can see that Casio FX 991 MS. This is the one which you have to purchase. Okay, please go to the original Casio showroom and purchase it.
It's a scientific calculator, sir.
Yeah, it's a scientific. We can use the normal calculator, but if you want to purchase a scientific calculator, that is the model which you have to purchase. Okay, FX 991 MS is the calculator which is allowed. I don't know why it's not allowed. Let me just confirm. Okay. So.
Okay, sir.
Thank you.
Yeah. Okay, no problem. So what you need to do is very simple. We will now fill up the table. Okay. We will fill up the table. First one, CJ. First one is CJ. Now on top of that, you have to fill up the coefficients of the objective function. What is the coefficients of the objective function? For x1, it is 8. For x2, it is 10. For x3, it is 7. Correct? Yes or no?
Yes, sir.
So write it exactly on top of that. 8, 10 and 7. Exactly on top of x3. 1 second. Your table should look something like this.
Yes, sir.
Okay. Right? Okay. Continuing further. Now objective function coefficients we have. Sorry?
Okay, sir.
Okay. Now proceeding further, what we have to do is, we have to first introduce the slack variable. Remember the concept. The concept is very simple. He says that slack variable has to be first introduced because slack variable is called as uncertainty. It's very simple. How? Let me ask you a question. Okay, let me ask you a question. Supposing there are 10 classes which you have to attend. Day 1, sharp 9:30, I attend the class. Day 2, sharp 9:30, I attend the class. Day 3, sharp 9:30, I attend the class. Fourth day, if somebody is asking, will he attend the class? Most of the cases, most of the people would say, yeah, he's correct. 9:30, he should be there here. Okay. So which means to say that you can predict with a certain amount of certainty that, okay, yeah, he is going to be present. Okay, let me give another example. Day 1, he is present, but class is at 9:30, but he joins at 11 o'clock. Day 2, he's absent. Day 3, class is at 9:30, he joins at 11 o'clock. Day 4, he's absent. Now, if I ask a question, day 5, will he come or not? Will he be present or not? I have certain sense of uncertainty. I cannot give a right answer. I cannot judge to a certain degree that yes, he is going to attend. No, not possible. So in the same way, this slack variable which is there in the table, it is like an uncertainty. That is why in simplex table, what I do is first I introduce the uncertainty and I first remove the slack variables. One more tip which I want to give you again is if you are solving the simplex method, if you are solving the simplex problem, always, most of the cases, what happens is when you are doing the procedure, the slack variable will leave the simplex table and the basic variables will come in. At least anyone share? Okay, right? So the basic variable should enter the table and the slack variables should leave the table. If that happens, clearly it's an indication that you are on the right track. Your problem, whatever you're doing, is right. But however, there are certain restrictions or there are certain peculiar types of problem where the slack variable doesn't go out. The slack variable will be there in the problem. Okay, so don't get panicked, okay, saying that, okay, the slack variable is still there in my table. Am I doing right or wrong? Don't worry. First thing is you need to have confidence when you're solving the problem. Okay, so first what I do, I introduce the slack variable and my objective is I have to remove the slack variable. Okay, that is how it is. That is how it is. So I am going to first fill down the slack variables under XB. Under XB, you put S1, S2, S3. Under XB, you put S1, S2, S3 because there are 3 slack variables. Okay. Now, corresponding to that, the cost of the basis, corresponding to that cost of the basis, I don't know what is the value of the slack variable. So unanimously for all the simplex problems, first you have to introduce the slack variable and 0. All 3 variables of slack variable should be set to 0. Okay, so put the 3 zeros there. So now your table, see, I will solve only one problem. Whatever problem you give, I will solve only one problem. Listen carefully, understand the concept, and then you can solve any problem. Okay, so understand. So this is how your simplex table will look. Okay. Right?
Yes, sir.
Yes, sir.
Okay. Now I need to fill all these. So what is all this? All these are the coefficients and the solution. Okay. So I will write along with me. First equation. X1, X2, X3. What is the first equation? 1, 3, 2. Correct? 1, 3, 2. Stop it there. Go to the next row. What is the second equation?
1, 5, 1.
1, 5, 1. 1, 5, 1. Correct? 1, 5, 1. That is what is the second equation which I have done. Is there any third equation?
No.
There is no third equation. So all the coefficients, I don't have any coefficients. I don't have the equation. So set all the 3 things to 0. 0, 0, 0. Understood?
Yes, sir.
Yes, sir.
Okay. So now my table looks something like this.
Yeah.
Yeah.
Now what I need to do? I need to fill out this S1, S2, S3. This S1, S2, S3 is basically called as the identity matrix. Anybody knows what is identity matrix? One is identity matrix. I asked what is identity matrix?
I mean, all the values will be same. All values only one.
All values will be same. 1, 1, 1, 1, 1, 1, 1, 1, 1. That is identity matrix. Sri Nisha, all values are 1. How? Forgot. Okay, right.
Diagonal.
Yeah, diagonal things will be 1. Okay, 1, 0, 1, 0, 1, 0, 1, 0. Which is that new helpline number? Okay, okay, right. Very simple. Identity matrix is very simple. Whichever matrix, if you are going to multiply with the identity matrix, the solution does not change. That is what is identity matrix. It's a mirror, correct?
Yes, sir.
Right? So your teacher would have multiplied a particular matrix, either a 2 cross 2 or a 3 cross 3 matrix with identity matrix. And if you multiply the row and the column, matrix multiplication, the resultant matrix will be the same. The resultant matrix will not change, correct?
Yeah.
That is what is identity matrix. Identity matrix is just like your reflection. You stand in front of the mirror, you can see you can't see somebody else. Okay. So you have a 3 cross 3 matrix. You have a 3 cross 3 matrix. So what happens is you need to fill that. Let me fill that. Fill along with me. First row 1, 0, 0. 1, 0, 0. Second row 0. Sorry?
Can you be little clear about the identity matrix, sir?
Identity matrix. Okay. Identity matrix is any matrix which is going to give you the same result. See, whenever you don't know any value, it is best to first allocate that particular value to 0. Okay. So for the slack variables, I put it to 0. Then inside, I want some matrix. I want some matrix which will not alter my solution. So what I do is I use the identity matrix. I need to fill that particular matrix. So I use the identity matrix. So what is the identity matrix there for a 3 cross 3? 3 cross 3 identity matrix is 1, 0, 0, 0, 1, 0, and 0, 0, 1. Now get the concept. Now the table looks something like this.
Yeah, sir, it's clear now.
Okay. Now, what is the solution? Solution is whatever values which is coming after the inequalities. So I have 10 and 8, correct? So write it down. 10, 8. I don't have any other solution for the third equation. So put it to 0. So now your table looks something like this.
Okay.
Right?
Yes, sir.
Okay. Okay. Next. Under S3, you put something called as ZJ. You need to put 2 more rows. One is called as ZJ. Another one is called as CJ minus ZJ. Can you see in the table?
Yeah, sir.
Yeah. Yeah, sir.
ZJ, CJ minus ZJ. This is the full simplex table. Your complete simplex table looks like this. Now what is ZJ? ZJ is basically called as net change. Net change. NETCHANGE. Net change. Okay. What is CJ minus ZJ? Net effective change. Net effective change. Okay. Net effective change. Now listen carefully. Now you need to listen carefully. What you need to do now is very simple. How do I get the value of ZJ? Can you see ZJ here?
Yes, sir.
In my camera? Okay. How do you get ZJ? Very, very simple.
multiplying CB with
0 into 1, 0 into 1 plus, I want silence. 0 into 1 plus 0 into 1 plus 0 into 0. Write the value here.
0.
0, correct. Next.
Sir, repeat it again, sir. I can't get you.
1 second. Can you see it? 0 into 1 plus 0 into 1 plus 0 into 0. Write that down.
Okay, sir.
Same thing you do it for all the things. 0 into 0 like this. I'll tell you. 0 into 3, 0 into 5, 0 into 0. Write it below. Can you see that?
0.
So, listen. Always in all the problems, the slack variable is set to 0. Okay. So unanimously in all the simplex table, first simplex table, remember, first simplex table, the value for Zj will be equal to 0. Very, very important. Only in the first simplex table.
Okay.
So unanimously, what you can do, first simplex table, Zj, unanimously put 0. Don't waste time. So what I'm going to do, 0, 0, 0, 0, up to solution, sorry, up to S3. Solution also 0. So your table looks something like this.
Yeah, sir.
Okay, right? Okay, now proceeding further. Cj minus Zj. Where is Cj? Cj value is at the top.
Top of the table.
Where is Zj? Zj is at the second last row. Correct?
Yeah.
Now,
so
Cj minus Zj means what? 8 minus 0. How much?
8.
10 minus 0. How much?
10.
7 minus 0. How much?
7.
The remaining 3 boxes, you put a star mark there on the top.
Okay.
Here.
Yeah, clear.
Sir.
Okay.
Yeah.
So here again, you will not get any values. So you put star.
Sir, can you show the table once again?
Sir, one second. Can you
show the table once again?
Can you just tell from where the Cj values come, sir?
Cj value is on the top.
No, sir. From where did you get the Cj value?
Cj value is basically coefficients of objective function.
Okay, sir. 10, 8 only there, no, sir?
8, 10, and 7.
Three variables, ma. X1, X2, X.
Okay, sir.
That is the maximized value only, no, sir?
Yeah. No, maximize that equation.
Okay, sir. Okay.
So that is what is the coefficients. Can you see here? That is your 10, 8, and 7 here.
Yeah.
Yes.
That is what I have put it as the Cj value on the top.
Yes, sir.
Then Cj minus Zj. So that will be 8 minus 0, 8, 10 minus 0, 10, 7 minus 0, 7. And then you have 3 star marks. So below also you have 3 star marks. You have no value there.
Okay, sir.
Okay, right. All right. Right. Now what you need to do? In the Cj minus Zj row, listen carefully. In the Cj minus Zj row, select the highest value. Select the highest value. Which is the highest value?
10.
Put one arrow mark there. Put one arrow mark there and mark that column. Mark that column. Like this. I can't join WhatsApp group. How to join WhatsApp group? Kindly create some. I don't know Girija and Anita. Okay. So many people, unknown people also are joining the WhatsApp group. Okay. Right. Okay. You see here, concept is very simple. Whichever is the highest value in the Cj minus Zj row, I mark that corresponding column. That column is called as my key column. That column is called as my key column. So you can put it as KC. Like this, KC. Key column. I marked it there. Okay, create finance department group.
Okay, sir.
Now it's according to the specialization. Okay, right. So this is KC KC your key column. You're going to select. So the procedure says that you're going to select the first. First, you're going to see which is the highest value in the Cj minus Zj row, and that corresponding column would be my key column. Okay. Now. This I got. Now I want my key row. How do I get my key row? Very simple.
Solution by the key column.
Yeah. How do I get the key row? I have 3 rows. I want silence. Okay. Thank you so much. So what he says is I am going to divide my solution. I am going to divide my solution with the corresponding value in the key column. Okay. So this is the corresponding value in the key column. Okay. And this is my solution. See, people can mute me so that I don't get back that voice. Yeah, fair enough. Okay. So this is the corresponding value in the key column. This is my solution. So whatever is the solution, you divide it by the corresponding value in the key column. And then I am going to see the least positive. I am going to see the least positive. Okay. I am going to see the least positive. Okay. No missed calls. Already I am getting a lot of calls. Okay. All right. So listen. Minimum positive ratio. What is the solution? Yeah, it is 10 divided by. What is the corresponding value? 10 by 3. Correct?
Yes.
10 is the solution. Corresponding value is 3. 10 by 3. Correct?
Yes, sir.
Yes,
okay,
sir.
What is the next one? 8 by 0.
5.
8 by
5. 8 by 5. Okay, and next one is
0 by
0 by 0. 0 by 0. Correct?
Yes,
Can you see this?
Yes, sir.
Okay. Now you see here 0 by 0. Now find out the value. 10 by 3 is what? 3.33.
3.3.
Okay. 8 by 5 is how much?
1.6.
666 recurring.
Yeah, 6.
Okay. 0 by 0 is 0. Correct? So this is how your table looks.
Yeah.
This is how your table looks. Correct?
Yeah.
Yes,
Now,
sir.
see carefully. Minimum positive ratio. Now 0 is positive. There are so much of confusion that 0 is it positive or yeah.
Will you show the table, honey, sir? Okay, so we are putting this value in the minimum positive ratio, right? 10 by 3 and
Correct.
And the second one is 8 divided by 5, right, sir?
Correct.
Yeah.
Thank you, sir.
No problem. Okay. So 10 by 3 is 3.33, 8 by 5 is 1.66, 0 by 0 is 0. Okay. Now what you need to do is very, very simple. You are going to select the least positive value. This is where students commit mistake. I have seen in one problem, wherein students, they will get 3 values, -3, 0 and 4. They will select -3 and continue with the problem, which is wrong because the table clearly says minimum positive ratio.
1.6.
You can't consider negative. You can't consider negative values. Correct? No?
Yeah.
Sir.
Even though -3 is
Yes,
less than 4 or 3, you can't consider negative values. You have to consider only positive values. Now what's happening here? Very, very simple. You have 3 values, 3.33, 1.66 and 0. Which is the least?
1.6.
0.
0. So mark that thing. Mark that thing. Now, according to the problem, if you go with the procedure, 0 is my least value. So it should be like this, correct?
Yeah.
It should be like this, according to the procedure.
Yes.
Whereas, if you see in this problem, there is no third equation, correct?
Yeah.
You have arbitrarily put 0, 0, 0 there.
Yeah.
Which means to say you shouldn't be taking that. Are you getting my point?
Yes, sir.
Yes, sir.
So you need to consider the next least value.
That is a 1.6.
1.66.
1.6666. Okay, that's recurring. Kitchen lab. That's recurring. Okay.
Okay, sir.
So what you need to do? Very, very simple. Go to that corresponding S2. Go to that corresponding S2 and mark that row. That is your key row. KR.
Where, sir?
Second row.
Till S2, sir?
Yeah, till 1.66. Mark the full thing.
Okay, sir.
Okay, right? So now you mark that particular second row. Now what is the procedure? The procedure is very simple. The procedure says that now my entire table is filled. The remaining and all are stars.
Yeah.
My entire table is filled. Now what he says, I have marked my key column. I have marked my key row. Okay. The intersection of the key row and the key column. The intersection of the key row and the key column gives me the key element. Gives me the key element. KE. I see here. So which is the key element?
5.
Which is the key element?
Number 5.
Which is the key element? 5, correct?
Yes.
So 5 is the key element. Okay. Now the procedure says that whenever I proceed from the first simplex table to the second simplex table, my main thing here is I have to first make the key element to 1. I have to make the key element to 1. and all the other elements in the key column to 0. That is the procedure. You can write down the procedure. When you are proceeding from the first simplex table to the second simplex table, when you are proceeding from the first simplex table to the second simplex table, I am going to make the key element to 1. The procedure is same. I am going to make the key element to 1 and other elements in the key column to 0. Other elements in the key column to 0. Okay. So if you have 2 equations, one will be the key element, other one you should make it to 0. If you have 3 equations, then one will be the key element, and another 2 you have to make it to 0. Understanding?
Yes.
Yes, sir. Yes, sir.
Okay.
Sir, how many tables we have to make, sir, for a problem?
That is the next question. How many
Sir,
tables?
5 K ன்னு சொல்றீங்க புரியல. 5K ன்னு சொல்றீங்க அது எப்படி வந்தது?
Intersection of the key row and the key element. Key column, see. Can you see?
Yes, sir.
Where it is intersecting?
Center.
யார் question கேட்டது?
நான் தான் சார், புரியல எனக்கு. அது மட்டும் கே மட்டும்
இல்ல. எங்க கீ காலம் எங்க கீ ரோ இன்டர்செக்ட் ஆகுதோ அந்த எலிமெண்ட் தான் கீ எலிமெண்ட். எங்க இன்டர்செக்ட் ஆகுது?
5 சார்.
ஆமா, அங்கதான். அதுதான் கீ காலம், அதுதான் கீ எலிமெண்ட்.
அப்ப 0 கீழ இருக்கே அது சார்.
0 கீழ இருக்கா? அது இன்டர்செக்ட் ஆகலையா? அது that is not to be considered.
Okay.
Don't consider that.
Okay.
You have to consider the one which is above, because that is I have just put that because there are 3 equations. There is no third equation in your problem. Can you see that?
Okay, yes, sir.
That's why you shouldn't consider that. It is just for filling up the table.
Okay.
All right. Okay. So 5 is the key element. How do you make the key element to 1? Follow that procedure. Whatever is the key element, divide that entire row by the key element. So old row, you put old row OR. Okay. Put that. Write that elements. What are the elements? The element is 1 5 1 5 1 0 1 0 1. Okay. 8. So the old row is 1 5 1 0 1 0 8. So this is the old row, correct?
Yes, sir.
Now what I am going to do, I am going to divide this entire row by 5. Can you see that?
Yes, sir.
Okay.
Can I say 1 second, sir? Not.
ஒண்ணுமே இல்ல, அந்த ரோவை எடுத்துட்டு எழுதிக்கோ தனியா.
Okay, sir. Okay.
எடுத்துட்டு தனியா போட்டுட்டு divide that entire row by 5. So what do you get? 1 by 5, 5 by 5, 1 by 5, 0 by 5, 1 by 5, 0 by 5, 8 by 5. Correct? So what is the resultant? 1 by 5, 1, 1 by 5, 0, 1 by 5, 0,
8 by
1.66.
1.6.
So this is the Are you getting this? This is called as the key row by key element. Correct? No? In the table, next table, next class.
Yes, sir.
Yes, sir.
Free class.
Yes, sir.
Okay, fine. Sorry for that. So this is how it is.
Okay.
Can you see that?
Yeah.
Yes, sir.
Okay, can you see that? Okay. Okay.
Okay,
Done?
sir.
Okay. Right. So now what you need to do is you got 1 by 5, 1 by 5, 0, 1 by 5, 0, 1.66. Now this is called as the key row by key element because that 1510108 that is called as your key row. Correct? Can you see that simplex table? You see the table.
Okay.
If you see this table, that 1510108, this is your key row, no?
Yes.
Yes, sir.
When you divide it by the key element, it becomes key row by key element, correct?
Yes. Yes, sir.
So that is what is this. I have written key row by key element. I have put that value.
Okay.
Now next step, I will put old row, which is the now I have made this 5 to 1, correct? So key element I have made it to 1. Understood?
Yes.
See here, I have made it to, it was 5 here, I made it to 1.
Yeah.
Now next, I am going to make the other elements in the key column to 0, which is my other element. There are 2 equations. One is 5, another one is 3. I have to make that 3 to 0, correct?
Yeah.
So what I have to do, write that row. 1 3 2 1 1 3 2 1
0 0
0 0 8. Sorry. 10. I'll write that. Okay. Below that, I will write my key row by key element. Below that, I will write down my key row by key element. What is that? 1 by 5, 1 by 5, 0, 1 by 5, 0, 1.66. Correct?
Yes, sir.
Now, if my procedure is correct till here, whichever element I want to make it to 0, below that I should have 1. Can you see?
Yes, sir.
See, now which is the element which I have to make it to 0?
3.
What is the element below that?
1.
Is my procedure correct?
Yes, sir.
Yes, sir.
Okay. So I am getting it like this, correct?
Yeah.
Okay, now what I do, I have to make that 3 to 0. I have to make that 3 to 0, correct now?
Yes.
So what I do, I multiply that key row by key element, whichever row is there below, I multiply it by the same element and subtract. I multiply it by 3 and subtract.
Okay.
So what do I get? So what do I get? 3 into 1 by 5 is 3 by 5. 3 by 5, 0, 3 by 5, 0, 1.66 into 3, 4.98. Correct?
Yeah.
Yes, sir.
Now I will subtract. Old row and this one, the row which I have got just now. So it will be 1 minus 3 by 5. 3 minus 3 is 0. 2 minus 3 by 5. 1 minus 0. 0 minus 3 by 5. 0 minus 0. And 10 minus 4.98.
4.98.
Can you see that? You can make a note.
Yes, sir.
Anyone, please tell me page number. I don't know, ma. Page number, I don't know which problem where they have taken, but this is the problem.
Okay.
Mute. Yeah, thank you. Can you see that?
Yes, sir.
Okay. Now, see here, one more thing I want to tell you here. Can you see the first simplex table? Can you see the first simplex table?
Yes,
Can
sir.
you see the first simplex table? In the first simplex table, no. KC is coming in. Okay? KC is coming. Table. KC is the column. KC is the key column. Okay? KR is the key row. Now, if you see the key column, come on the top, which is the variable you can see?
3.
No. Variable.
10.
X 10. 10. 10. 10. 10.
Variable.
10. 10. 10. 10. 10.
X2.
Sorry, sir.
X2 is the variable that is entering. Can you see that?
Yeah.
Yeah.
It's entering. See here. K column. I put a up arrow mark.
Yeah, sir.
Yeah.
Which is leaving.
Yes, 2.
X2 is leaving. It is replaced by X2. Correct?
Yeah.
Yes, sir.
Like this it should happen. X2 should, basic variable should enter, slack variable should leave.
Okay.
Understood?
Yeah, sir. Understood, sir.
Okay. Now tell me what is this values. Tell me what is the values.
So once again, sir.
Sir, the X2 should go on.
So can you tell once again how slack variable is used?
How slack variable?
It's giving and how the X2 is entering.
You are putting an arrow mark here. Up. Here. KC.
Yeah.
So that is entering. You have put an arrow, upward arrow mark.
Okay.
And you have put an outward arrow mark here for S2.
Okay, sir.
So that is entering, this is leaving.
Okay, sir.
Got it?
Yeah, okay, sir. Got it.
Okay. Tell me the values for this. 1 minus 3 by 5. 5
2 by
minus 8.
2 by 5. 0. 1 by 5.
Minus 5 to 7 by 5.
0. 0. 5.34.
1 minus 0 is 1. 5 minus 0 is 5. 5 minus 3 is 2 by 5. 0 minus 0 is 0. 10 minus 4.98 is
Yes,
how much?
sir.
5.34. 5.02. Silence. Okay. So whatever you have got here, this is your new row. NR, new row.
Sir, show your note papers 1 second. Thank you.
Okay. So this is your new row. Now what you need to do? Very, very simple. See here. what you need to do here, now you have got all the values. What is that? Key element, I made it to 1. Remaining elements, I have made it to 0. Correct? No. See, that 3 which was here is made to 0. Correct? Okay. So now you need to put one more simplex table. You need to put one more simplex table, just how you have put in the previous case. Simplex table 2.
Okay.
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 So which is the next simplex table? You have to put the same simplex table, but with some modification. What is the modification? Which is entering here x2, correct?
x2, yeah.
Which is leaving?
S2.
S2. S2 is leaving. So when S2 leaves, that place becomes vacant. It has been replaced by x2. So put that simplex table. Put the simplex table. So again, CB, XB, S1, S2. Okay. So what is leaving? Leaving is S2. Correct? No. S2 leaves. X2 enters. So X1, X2, X3, S3, X1, X2, X3, solution and minimum positive ratio. Correct? No.
Show here.
1 second. CJ, and then what is the table? 8, 10, 7. So your table should look something like this. Correct?
Okay, sir.
So S2 has left. It has been replaced with X2. When S2 was there, that value was 0. Now X2 is there, that value is 10.
Okay, sir. It's clear.
Okay?
Okay, got it.
Okay, right. Now you need to fill the values. Now you need to fill the values. Very, very carefully you need to fill the values. This S3, I have not done any modification because there is nothing here, correct?
Yeah.
There is no equation. So write it as it is. So what is that? 0, 0, 0, 0, 0, 1, 0, correct? No. So write it as it is. 0, 0, 0, 0.
So
1,
table
0.
2 once again, sir.
Okay?
Yeah, okay.
Right? Next, see here. In the first simplex table, where was the key element? Here, correct? No?
Yeah.
Key element was here. That is in the second row. Now this I made it to 1. 5 I have made it to 1, correct?
Yes, sir.
That I have made it here. That is here. This particular thing, key row by key element. You have to write this in that same row. That is here.
Yes.
In the second row, instead of 5, I replaced it with 1. You should not put it in the first row. Then the problem will go.
Okay.
Got it?
Got it.
Means 1 by 5, 1 by 5.
Correct. So what is that? That will be 1 by 5.
1 by 5.
1
0
by 5. 0. 1 by 5. 0. And 1.66.
1.66.
Correct?
Solution. Yes, sir.
Yeah, sir.
Right? Okay. Now, after this, there is one more row which is pending, and that is your new row, whichever you have got here. The remaining, that 3 you made it to 0.
Yes, sir.
That one. So what is that?
2 by
that
5.
That will be 2 by 5.
0.
1 by 5. 1.
3 by 5.
0. 5.0.
5.34.
0. 2 by 5. 7 by 2 by 5. 0. 7 by 5. 1 1. 2 by 5. 0 and how much?
5.02.
5.02. 3, 4. Sorry. 1, 2, 3, 4. So it is, I'm getting some extra values. 1 minus 3 by 5 is 2 by 5. So 2 by 5, 0, 7 by 5, 1, 2 by 5, 0.
No, sir. No, sir. 7 by 5, 1, minus 3 by 5.
Sorry?
Sir, 2 by 5, 0, 7 by 5, 1, minus 3 by 5, 0, 5.02.
Okay, I missed out one. Okay, minus 3 by 5, 0.
5.34.
Okay, 0, 7 by 5, 1, minus
5.02.
3 by 5, 0, and 5.02. Correct? The table looks something like this.
Yes.
Perfect, sir.
Okay, now ZJ, same thing. Now you will not get 0. 0 into 2 by 5 plus 10 into 1 by 5 plus 0 into 0. Correct now?
Sir, once again, sir, the second table. Let's explain, sir. On the 10
okay. So ZJ, how do you get 0 into 2 by 5? 0 into 2 by 5. Correct? Plus 10 into 1 by 5 plus 0 into 0. What is the answer? 2. Next one, 0 into 0 plus 10 into 1 plus 10 into 0. 10. 0 into 7 by 5, 0. 10 into 1 by 5 is 2. 0 into 0 is 0. So it will be 2. Then remaining thing, 0 into 1, 0. 10 into 0, 0, 0. Next, 0 into minus 3 by 5, 0. 10 into 1 by 5 is 2. 10 into 0 is 0, so 2. So 0 into 0, 0 into 10, 0 into 1, again will be 0. 0 into 5, 10 into 1.66 will be how much? 16.6. 16.6. 0 into 0 is 0. Okay. So you got this value, correct?
Yes, sir.
Right?
So once again.
Yes, sir. Yes, sir.
Okay.
Yeah.
All right. Next. Okay. Next. CJ minus ZJ. 8 minus 2 is how much?
6.
10 minus 10 is how much?
0.
7 minus 2 is how much?
6. Sorry, 3.
5.
Sorry, 5.
Okay. So this is the table.
Okay, got it.
Okay.
Last.
Okay, right? Now, now what you need to do is, the procedure keeps on repeating. The procedure keeps on repeating. Till when I have to do this procedure? You have to do the procedure until and unless all the Cj minus Zj values are 0 and less than 0. If you see carefully in my first simplex table, what is the Cj minus Zj values? Can you read out?
0, 8, 10, 7.
8, 10, 7, correct?
Yeah.
What is the Cj minus Zj value in the second table?
605.
It means to say the values are coming down, the values are reducing, correct?
Yes, sir. Yes, sir.
So at one point of time, the particular values becomes 0 and less than 0.
Okay.
Until and unless you have to follow the same procedure. When you are getting 0 and less than 0, you stop the procedure and then you have to take the value of corresponding solution. You have to take the corresponding solution values and multiply. Okay. So what I want you to do is, after lunch, again, I'll be having, one second. Listen, 1:30 to 3 o'clock, I will continue this particular problem. Okay, this is a lengthy problem. So 1:30 to 3 o'clock, I will continue this problem. Link will be the legal systems link, which is given in the university website. Okay, and one more thing is 3:15 to 4:45, you will be having legal systems in business. Okay, legal systems in business, you will be having same link whichever is there on the website. So you join in at 1:30 to 3 o'clock for applied operation research. We'll complete this problem. Okay, right? So I will finish that particular problem. You want to take over? Okay, fine. So I have one extra hour, so I will take that particular class also. As of now, we will continue the problem. Okay, till 12:45. Link will be legal systems in business. Join in with the same link. Okay, I'll only be coming and we'll solve some more problems. Okay. So now you got this much. Okay, 605. You have the new Cj minus Zj row. So I have to continue this procedure unless and until I get all the Cj minus Zj values as 0 and less than 0. It will happen. Okay. When that happens, you have to stop the procedure. Most of the people ask me till when I have to keep doing this process. You have to do the process until and unless all the Cj minus Zj values are 0 and less than 0. Okay. Okay, now proceeding to simplex table 3. In simplex table 3, now go to simplex table 2. Which is the highest value?
6.
Put an arrow mark there. Mark that is your key column. That is your key column. Okay, right? So mark there as KC, same procedure, mark there as KC. Then go to minimum positive ratio, in that, what you need to do? 5 divided by 2 by 5, correct? 5.02 something, correct?
Correct, sir.
So what is that? 5.02 divided by 2 by 5. So that will be 5 divided by 1 into 5 by 2. So that will be 25 by 2. That is 12.5. Correct?
Yeah.
12.5. That will be the first value for minimum positive ratio. Second one. 1 by 5 divided by 1.66. So that will be 1 by 5 into 1.66 by 1. So that is 1.6. So how much is that? 1.66 divided by 5 is how much? 0.33. 0.33, that's the next value. The next one is 0 by 0 is 0. You are not considering that. Okay. So both are positive. Both are positive. 12.5 and 0.33 both are positive.
Sir, 1 second. 1.66 divided by 1 by 5 will become 5 into 1.66, right?
1 second. 1.66
divided by 1 by 5. It should come.
How much is that? 1.66.
8.3
divided by 1 into 5 by 1. So 1.66 into 5 times.
5, yeah.
How much is that?
8.3.
8.3. 3. Okay. Correct. 8.3. So put that as 8.333 recurring. So you have two values like this. You have two values like this. So one is 12.5. Another one is 8.33. 8.33. Okay. So both the values are positive. Both the values are positive. Whichever is the least value. Least value is what? 8.33. Correct?
Yeah.
8.333. That is the value. Okay. Now mark that row.
1 by 5 intersection.
Mark that row. That is called as the key row. Okay. Key row. Okay. That is called as the key row. Right. So what is the intersecting element? The intersecting element is 1 by 5. So that is the key element. Now you see here. What is entering?
X1.
X1 is entering. Correct?
Yeah.
What is leaving?
X2.
It's a very nice problem. You see here, I was telling when I was explaining in the first session. Okay. I want silence, please. You can all mute yourself. Okay, see, listen, when I was explaining in the first session, I told you that there are certain problems where it will go against the rule. Slack variable should leave, basic variable should enter. But there are certain problems where the slack variable will not leave. The basic variable itself will go out. This is one such problem. Okay, wherein the basic variable is replaced with another variable. This indicates that, what does this indicate? This indicates that X2 is less powerful and X1 is more powerful. So X1 is entering. It is replacing X2. Okay. So which means to say what? In place of X2, I am going to put X1. Okay. In place of 10, I am going to put what is the corresponding X1 value? 8. Correct?
8.
Yes.
So that will be my next simplex table. And what is the key element? The key element is 1 by 5. That I have to make it to 0. Sorry, I have to make it to 1.
1.
And the other element, which is the other element? The other element is 2 by 5.
2 by
that
5.
I have to make it to 0.
Yeah.
Can you solve it and tell me the answer?
Yeah, sure.
Yeah, solve and tell me the answer.
It's right.
You can add me on the WhatsApp group for sharing the YouTube links, Facebook links, and the class links. Okay, you can add me, no problem. Okay. So this would be the key row by key element.
Key row by key element. Yes.
This would be the key row by key element. Then let me take the old row. What is the old row? in the second simplex table. The
2 by
old row
5.
is
2 by 5. 0.
7 by 5.
7 by 5. 0. 7 by 5. 1. Minus 3 by 5. 0. 5.0.
Correct. Now I am going to put the key row by key element below. So 1, 5, 1, 0, 1, 0, 8.3. So what I am going to do, which one I have to make it to 0? 2 by 5.
2 by 5.
Multiply this key row by key element by 2 by 5 and subtract. So 2 by 5 into 1 is 2 by 5. 2 by 5, 5 into 2 by 5 is 2. Okay. And 1 into 2 by 5 is 2 by 5. 0 into 2 by 5 is 0. 1 into 2 by 5 is 2 by 5. 0 into 2 by 5 is 0. 8.3 into 2 is 16.3 divided by 5 is how much? 3.332. So this is my new row and this is my key row by key element. Can you see this? Have you all got this answer?
Yes.
They are not clear, sir.
Sir, and then we need to subtract, right? We need to subtract.
Yeah, we need to.
Yeah.
Sir, can you explain once again, sir, for this one?
See, what we need to do, we need to make, whenever you are going from one simplex table to another simplex table, we need to make the key element to 1 and other element in the key column to 0. Okay. Now in this, the key element is 1 by 5. So 1 by 5, I have to make it to 0. Okay. And the remaining element, what is the remaining element? 2 by 5. That I have to make it to 0. Okay. So what I do, I have to make the key element to 1. So if it is 1 by 5, I divide it by the same key element. So I got it as 1, 5, 1, 0, 1, 0, 8.3. Okay. Now next, I have to make 2 by 5 to 0. So what I do, I first write the old row, whichever I have got it from my previous simplex table. That is 2 by 5, 0, 7 by 5, 1, minus 3 by 5, 0, and 5.02. Okay. Then I write the key row by key element, whichever I have got it just now. So that is 1, 5, 1, 0, 1, 0, 8.3. Correct? Now,
yes, sir.
I have to subtract both the things. How do I get that to 0? I have to multiply this key row by key element with the element which I have to make it to 0. Now 2 by 5 is the element which I have to make it to 0. So what I do, I multiply this key row by key element by 2 by 5 and then I subtract. So what I do, 2 by 5 into 1 is 2 by 5. 5 into 2 by 5 is 2. 1 into 2 by 5 is 2 by 5. 0 into 2 by 5 is 0. 1 into 2 by 5 is 2 by 5. 0 into 2 by 5 is 0. 8.33 into 2 by 5 is 3.26. That is the new row.
Can you please show it, sir?